Welcome to an introduction to workflow management with Prefect. Kevin is an open source community engineer at Prefect, and Prefect is an open source workflow orchestration management system. And I know Kevin can talk more about it. So let's get started.
Okay, so hey everyone. You see the slides, right? Just making sure.
Yes, we can see
Okay,
it.
all right. Okay, so hey everyone. My name is Kevin, and today I'll be talking about an intro to workflow orchestration. I work for Prefect, which is an open source workflow orchestration system. So I'll be explaining more about what we do, and I'll be giving some basics about showing the basics of using Prefect. My job is responding to like all of the mainly responding to support in the Slack channel. So if you are a Prefect user and you've asked questions, maybe you've seen me in Slack. If you're not, you're always welcome to join the Slack channel. We have a very active community. So for today's talk, just a quick overview of what we're going to go through. First, we'll build a simple Python script where we're going to be tracking the price of Dogecoin. And then we'll talk about what the potential pitfalls of that simple script are, like what happens when it fails and why can it possibly fail. And that's why we'll need a product like Prefect, where we can actually offload that sort of failure handling to a workflow orchestration system. So we'll learn about how to translate that into Prefect, and then I'll just give a quick demo of like how to use Prefect and Dask to parallelize flows. So first off, our main example here will be we want to track the price of Dogecoin, and when there is a dip in price past some certain threshold, I want to be alerted of that. And for today's talk, that's going to be in the form of a Slack notification. So for this talk, I used the CoinDesk API, and it's kind of funny because as I was preparing this talk last Monday, there was a massive crash, and like if you look at the top here, practically everything went down by 10% or more. So we are going to use the CoinDesk API to load the most recent prices, and then we'll see if there was a dip in those prices. So let's get started with our Python script. I won't show any of the imports since like that just ate up a bunch of space. So in general, we have 4 steps. The first step is we're going to construct the URL to use the API. Then second, we'll do a GET request. That is going to return a pandas data frame. And then from there, we're going to detect the dips in that pandas data frame. And if the dip is past a certain threshold, that's when we'll send the Slack notification. So there's really just 4 main parts to this. So the first part over here in format URL, which is quite a mess. The only important part is that we're hitting this URL, and we're going to be adding some parameters based on the start time, end time, and then we're going to format that string using the URL, the coin that this function takes, and the parameters. And then we have this get data function, which will format the URL based off the coin that we provide, get the data, and load it into a pandas data frame, and return the data. Next, once we have the pandas data frame, we are going to detect the dips. So this threshold is like a 10% dip. So we're just going to get the simple peak in the bottom. And then we're just going to do some like the bottom divided by the peak and seeing what percentage of the peak it is. And then 1 minus that gives us like what percent drop kind of. So and then if this dip is beyond the threshold, we return true, otherwise false. And then posting to Slack is actually a lot easier to do in Prefect. So I didn't bother like writing it out in the Python, but let's just assume that I have a post to Slack method that I'll figure out later. And once I make those 4 functions, it's a matter of putting my Python script into production. And what you'll see is that maybe I'll spin up some kind of EC2 instance or some compute, and I'll have this infinite loop that runs, and it's going to run every 5 minutes here. And then for every 5 minutes, we just get the data, detect the dip, and if there's a dip, I'll post to Slack. And of course, this will work for some time, but for real production systems, there's many things that can go wrong, and failure is bound to happen one way or another because these data systems tend to be complex. So like the first question, what happens if the API fails? Then my script will just die and my script will stop running and turn off because it's going to error out. And just a bunch of other questions. What happens if I wanted to track another coin simultaneously? I would probably need to run another version of the script in the same EC2 instance. What if I wanted an off-schedule run? Like I just wanted it to run it immediately. Then I'd probably need to do something like removing this while and just running this inner block and just firing off a run. And then lastly, we're doing the Slack notification, but a lot of times, like what happens like if the API failed and we want specific notification for that task, right? And what we find is that the more we try to safeguard ourselves against failure, the more and more the code actually becomes stuff guarding against failure rather than stuff we want to actually do, right? So for example, with the API, if I wrapped it with a try except, that would work. But then I'd need to, if in a real use case, I'd need to put try excepts in a lot of different places, put a lot of like notifications in a lot of different places. So if something fails, like how do we even deal with retries? Like what if I only wanted to try retry hitting that API a maximum of 3 times, and after 3 times I decided I didn't want to anymore? That becomes a bit more complicated, and that's why you should start to use a workflow orchestration system so that you don't have to code those yourself. So all of these things Prefect refers to as negative engineering. When we talk about negative engineering, it's everything that you are doing to handle failure, and in general, it's just things that detract away from the stuff you actually want to do, right? So here we count the failure logic, retries. You know, what happens when malformed data comes in? Is there like if there's an error, you want another set of code to execute, and then like notifications, failure messages. These are all examples of safeguarding against failure. And Prefect's goal is to eliminate negative engineering as much as possible. So before the company Prefect started, our founder, he talked to a lot of data engineers, and what he found was that some of them spend as much as 90% of their time on negative engineering. And if you can just reduce that to even 80%, then the developer productivity is doubling from 10% to 20%, where they can spend double the amount of time on positive engineering, the stuff that they actually want to accomplish. And that's where Prefect comes in. So we are an open source workflow orchestration company. So you can see us on GitHub. We currently have 6,300 stars. On Slack, we have a very active community with 5,600 members. In general, Prefect is Python-based, and it is designed for the modern data stack. So our founders are the founding team is like full of data scientists who wanted to bridge that gap between data science and data engineering, and make it easy to deploy your data science workflows in a reliable way. Prefect is also built on top of Dask, and we'll go a bit into that later. But this means that we can utilize Dask for parallelism in our workflows. In general, we have a very active community. Again, it's my role to a lot of our Slack, a lot of our users go to our Slack community to ask for help when they get stuck using Prefect, and we make it a point to really try to respond to everyone. So attached to Prefect core, which is just the like Pythonic, the way you interact with Prefect and design your flows, we have backends also. So that's Prefect Cloud and Prefect Server. Prefect Server is open source, so you can some of our users just get Prefect server, put it in their own infrastructure, and spin it up that way. But of course, majority of our users use Prefect Cloud, where we manage that server for them. In general, yes, Prefect server is free, but you can also go into Prefect Cloud if you wanted to try out Prefect, and you get 10,000 free task runs every month, which is more than enough to get started. And with that, we'll start converting our previous Dogecoin tracker into a Prefect flow. So first, we need to discuss the workflow semantics of Prefect, and those are flows and tasks. So flows are comprised of tasks. So a task is more like a Python function, where it's like just a simple like one purpose piece of code, and flows are like the whole script, where it's a bunch of these tasks combined together. So here you're gonna see that I just the task decorator here is imported from the Prefect library, and all I'm doing, this code inside did not change at all, and all I have to do is decorate it with the task decorator. Sorry, and then this becomes a Prefect task. And the way to use it in a flow would be to just bring it into a flow. This logic again did not change so much, but all we're doing is putting it in the flow context manager, and now the flow context manager is the one responsible for running these tasks. The last thing I want to point out is this flow.run. So now we can easily run our script as if it were a Python script and get like output locally, seeing if our code works. And there's a couple of concepts here that show why Prefect is particularly unique. So the first, if you look here with this detect dip data, so data is the pandas data frame that we got from get data, and we pass that pandas data frame inside detect dip. And that's because Prefect supports first class passing of data. Other workflow orchestration systems don't, and you'd have to persist it somewhere and then load it in a downstream task. Or there are hacks that let you pass it, but those hacks result in the data being copied inefficiently. So Prefect supports passing of data as a first class mechanism. And then notice that I'm not setting like set upstream, set downstream. Prefect is taking in this data task and automatically setting that get data task as an upstream dependency. So it's a lot more Pythonic like to use. And then lastly is local testing. So some other workflow orchestration systems, you need to spin up everything just to get a local test working. Whereas in Prefect, you can just run it like a simple Python script. Now that we decorated our functions as tasks, now we can set the retries. So this is the task that's hitting the API endpoint with this request.get. Now we want to set a number of retries, just so if that API, fails, we can just easily retry after a minute. So here I'm just setting my max retries equals to 3, and I'm setting a retry delay with a time delta of 1 minute. And now this will run 3 times before it stops and is considered a failure. In general, you can set like task retries at the global level. So you can say you want all your tasks to retry. And then, of course, I may not always be interested in Doge, but I may want to use the same logic of my code to check something else, like maybe Bitcoin or Ethereum. So in that case, we would use parameters. So Prefect supports parameterized flows. So here we're defining a new parameter called coin. And this coin, the default value is Doge. And then this coin we're passing into the data task that was defined above. So there was a default value in this function called Doge. And now we can override that with like BTC or Ethereum, another ticker. And then we would get the data for that different cryptocurrency instead. We can also debug locally with the parameters. In this specific instance, what I'm doing is I'm saying flow.run, and I'm passing in the BTC, the Bitcoin ticker, as my parameter. And now the entire flow will run with BTC instead of Doge. And the last part of of our initial flow is that I said that posting to Slack is a lot easier to do with Prefect, and that's because Prefect has a task library. So we I showed you earlier how you would make a simple task. So a lot of our community contributors have contributed tasks to form this task library. And these are ready-made tasks that you can just like fill in the inputs for your use case, and you can use and then use them inside your flow. So we have a lot of Prefect users who are not as familiar with Python, but because of the task library, they're able to piece together, like, for example, they're loading in data from like a PostgreSQL database and pushing it somewhere else. Some of them use it to kick off jobs, like if you think of like Databricks jobs. And like in my specific use case, what I'm gonna do is I'm gonna get the Slack task here, and I'm gonna just configure it a bit so that I can use it inside my flow. And it's very simple to do that. So here, I'm just going to import the Slack task, and then I initialize it. I initialize this task with this message. There has been a dip in Doge price, and then I'm providing this webhook URL. And then now I can just easily use this Slack task inside my flow like this, and this will all work. There, what it does is this webhook secret specifically is a secret that's stored in Prefect Cloud. You can also store secrets as environment variables. So I have a secret that's stored on Prefect Cloud, and this Slack task will grab that secret and then use it inside the flow. So now if I run my entire flow, I'm gonna get this Slack message each time. And that's where we can apply some conditional logic inside of our flows. So the previous example, the previous code here with the dark highlight, that is the naive way we chose to run our Doge price tracker. And down here is the Prefect flow. So the important line is this: if is dip, then we'll post to Slack. In our case, we can use the Prefect task. The Prefect task. So I imported this Prefect case task, and then we're just checking for the value of is dip, which, if you remember, was true or false. If it is true, then we'll post to Slack. Now that we're ready to actually productionize this flow, all we have to do is change our flow.run to flow.register and provide a project name. And this registers our flow with Prefect Cloud, where we can like better orchestrate it now. And of course, the last thing before we actually register is providing a schedule. In our starting example, we wanted to run it every 5 minutes. So on the Prefect side, what I'm just gonna do is I'm gonna make a new clock, and the start date is now, which is just daytime UTC.now. And then I have a time delta of 5 minutes. And notice I can pass in a parameter to this clock. So parameters are associated with clocks. So if I wanted to have 2 different clocks, like one for Doge, one for Bitcoin, then I could just make 2 clocks and have this flow run both of those clocks, right? So now I can make a schedule, and the schedule just takes in a list of clocks. And then we can easily just pass flow.schedule equals schedule. And now when we register this, that schedule will be enabled, and every 5 minutes our flow will be running. So there's 2 ways to dictate how often like stuff will run, and that's with the cron clock and the interval clock. So that we see the interval clock here. The cron clock would take in a cron expression and evaluate that. And then aside from clocks, we also have filters and adjustments. So filters are related to like if you have a clock that says like every 2 hours and you don't want it to run on the weekend, then you would filter the weekends out and it would not run on the weekend. And then adjustments are like you can say, I want this to run on the next like weekday, and then they will bypass the filters. So together with these 3 provide like a very rich way to express the schedule you want to run your flows on. And with that, we covered the Prefect basics. We went over flows and tasks. We went over parameters, retries. You saw the task library and the Slack task. I used a webhook that I stored as a secret. And then we, instead of using if else, we changed that to the case statement that Prefect had to handle the conditional logic. And then I registered it with a schedule. But we're not done modifying it here, because we can actually do better. So with our with a more advanced prefect concept is mapping. So we can map the prefect task for parallel execution. So instead of just doing one coin, I'm instead going to change this parameter to a list of coins. And here I provide 3: Doge, BTC, and Ethereum. Now all I need to do is get the same task. I'm not changing this this is still the same logic from the original logic. And all I have to do is dot map coin, and this will run on all 3 already. And the second part is this dot map on the detect dip. And now I have 2 consecutive map tasks that the mapping gets chained together, and there's no reduced step in between. And then all I'm doing is collecting because this dip is now a list of true or false. It's a list of booleans. All I have to do is reduce that with this task that just gets, like, if there's a true value, the max will be true. And then now I can do this. I can reuse this with case dip true post to Slack. And the Dask engine will be used for parallel execution. So here I'm changing my executor. The normal is local executor, which is by default will evaluate them sequentially. Now I'm using the local Dask executor, which will use the 4 cores of my machine. And I can do these 3 coins simultaneously. These 3, I can do those map tasks simultaneously in a depth first execution manner. And the last thing I want to show is that we can actually offshore this to a Dask cluster that lives elsewhere. So for this specific example, I'm going to use Coiled. And I am creating a software environment for Coiled. This makes the Docker image that I can then use on the Coiled cluster. And here, now this top part is Coiled code. This bottom part is Prefect code. I am making a Dask executor and passing in this Coiled.cluster class. And now it will spin up the Coiled cluster. And then notice the shutdown on close is true. So it will run my flow and then spin down that cluster when it's not needed anymore. I attach that as an executor. So I'm about to wrap up here. What I'll show you is that number 1, I registered this on Prefect Cloud already. So I have this flow, which if you caught it, the name was To the Moon. And this is my my tracker, my price tracker. So I'm going to spin up a prefect agent. What this agent does is it pulls clouds to see if there's any flow running every 10 seconds. So now I want to show you that if I wanted to change the parameters, I could do it through the UI here. I put a threshold of 0 here just so I'll get that Slack alert that I can show you. And then over here in the dashboard, you see the history of the failed flow runs. If you open a failed flow run, you can see what task specifically caused that to fail and see the logs. For now, I'm just going to hit quick run over here and run the price tracker. And I'm going to start, and you'll see my agent will now pick it up. So it found the flow run and is deploying it. This flow run will take a bit because we're spinning up the Coiled cluster. So I'll get back to that, but I'll take questions now as we wait for this. I'm trying to open Zoom. Okay, so I got a question. Can flow.run, why is flow.run outside the context manager? Shouldn't it be inside of it? So the context manager is making that flow, but not executing it. And then the flow.run or flow.register is outside that context manager, and it will be the one responsible for running or registering it. if there's no other questions, I'll continue to share my screen here. Oh, I think I shared the wrong screen. So over here, in my Coiled dashboard, you're gonna see that a new worker has spun up, and this is because of the Prefect flow that is running. So if I check the logs, you're gonna see that this new cluster is being created. And then now the task actually, so the cluster spun up, it got ran on, the flow ran on the cluster, and then now it's supposed to spin down it'll spin down the Coiled cluster when in a bit. But then you should see in Slack, I got this message here, and this was the Slack task that detected that there was a dip in crypto price. And with that, I'll stop sharing.
Thanks, Kevin.
Okay.
So do you have another question?
Yeah. So there's a difference here. What is the difference with Airflow? Prefect, one of the Prefect founders was a maintainer for Airflow, and Prefect is basically a list of things that it's like rebuilding Airflow from scratch, right? So for example, you cannot flows in Airflow are attached to schedules, so you can and the timestamp is a primary key in the database. You couldn't have concurrent flows. I think they fixed this in 2.0. Aside from that, passing of data between tasks is a very big Prefect feature. Mapping is also a very big feature. The mapping, and there's also another operation called task looping. These are mechanisms to dynamically define your DAG in Prefect. So that's a very big Prefect feature. And then in general, just the way, the lightweight way that it wraps around your code. There's a very long blog post about the differences between Prefect and Airflow. It's called Why Not Airflow, and you'll find it on Medium. I can take other questions while I try to link that in the chat. I attached it to the chat. Okay, with that, I guess I'm done. If there's any questions, feel free to reach out to me on Slack, and thank you for having me and coming.
Thank you. Thanks, Kevin.